Hello class, and in this video I am going to show you how to manage your data for your half-life simulation, the one where we shook all those puzzle pieces around. If you look here, I already have my data put into sheets. Here in one column I have the number of shakes, and then here on this other column I have the number of pieces that are facing up, and as you can see the numbers diminish with more shakes that I do. Seems simple enough. So the first thing I should do is I should insert this into a chart. You can just click on this icon here, insert chart, or you could go to insert and go to chart. It looks very tempting to insert this column graph, but please do not. Instead, insert a scatter plot. It is a scatter plot, and if you insert a scatter plot, Google is going to do a bunch of cool things for us. So let's insert this. Here I have a lovely scatter plot, but I need to add a few things. Number one, I need to add a trend line. So let's click on a data point. Click on this arrow, which is for trend line. This is an exponential curve. Look how it's kind of curving, so it's not linear. So I'm going to click on the drop-down menu. Here it says exponential. Aha, and I have a very nice trend line, almost ready to be put into your lab write-up. But I am not done. The scatter plot function on Google is very powerful. Go here to this drop down menu and click on Advanced Edit, or you could right click it, not here, right click it and do Advanced Edit. In Advanced Edit, I want to show you a few things. Number one, if you just put your cursor on the trend line, the equation for the line shows up. That's awesome. Meaning in future labs, if you need the equation of a line, you just have to add the trend line with a scatter plot and the equation shows up. How cool is that? Additionally, I want to show you a very cool statistic. If you scroll down on the customization menu, there is a statistic here called R squared. R squared is the goodness of fit stat, or the goodness of fit statistic. So if you click on this, I have an R squared of 0.998, which is a really good value. This goodness of fit value talks about how well my data fits the trend line. And the closer to 1 it is, the better it fits the trend line. So that means I have like really clean data that's not kind of aberrant or has a lot of like crazy numbers here or there. Like it really fits what the math says it should look like. So that makes me feel pretty good. So let's update this. That looks great. The point of your lab is to find the half-life of your little shaking procedure, right? Like with how many shakes would you have half of the puzzle pieces facing up? We can do it visually because here it is on the chart, right? We could just kind of look here, all right? I went from 48, so I'm looking for 24. It's somewhere in this area. It's kind of hard to see. One thing that I can do is I could just click on the area here, right? And these little menus show up. So I could add more vertical grid lines. Maybe just do it auto. No, let's add more. Let's make 10. That's better. And then I can add more horizontal lines. I could add 10 here. And that helps out a little. So here, I know I want to get from 48 to 24. 24 hits it right around here. So it's between 12 and 24. So I'm going to guess like it's around 18. I'm going to guess that the half-life is around 18. I'm just going to type that down. Half-life is around 18 shakes. But there is a better way to find half-life. This is kind of a, kind of just kind of jimmying it, kind of eyeing it. That's not the most precise way to do it. Instead, let me show you how to use Sheets or Excel to plug in some math. Let me move this chart out of the way. You will need to copy and paste this into your lab write-up. And here, if you look here, there is an equation for half-life. Half-life is the elapsed time times log times 2, log 2, over log of the beginning time over the ending time. I know that seems like a lot, but really there's just 3 variables here. The elapsed time, the beginning amount, and the ending amount. So let's use Sheets. Let's have one be the elapsed time, one cell be the elapsed time, another cell being the beginning amount, and then the last cell being the ending amount. In many places, the variables here will be t, N0, and then NT. All right. The elapsed time, let's just say 15 seconds. In 15 seconds, it went from 48 to 26. In 15 seconds, 15 is T, N0 is my beginning amount, which was 48. And after 15 seconds, I had 26. I'm just going to use these numbers. Now I just have to plug in this equation, write this equation through Excel. To do that, I type in equal sign. When you type in equal sign, it starts a macro. It does a function for you. So equal sign, I'm just going to put in this stuff here, elapsed time times log 2. I'm going to put that in parentheses because I know it's above a dividing line. Elapsed time is this number here, so I'm just going to click on it, F2. All right, this is my elapsed time. See how it's highlighted? All right, times log of 2. You got to put parentheses here, log parentheses 2. Good. All right, and I got to do another parentheses because I had one here already. And then I'm going to divide it by log. So I'm going to do a parentheses down here, log parentheses the beginning amount, which is here. I'm just going to click here on the 48, divided by the ending amount, which is 26. I'm going to close parentheses, and I think I'm good to go. There you go. And my half-life this time is 16.95 or 17. So the half-life is actually around 17 shakes. This is critical information to put into your lab write-up. So I'm going to change it here I'm not going to do it around, is 17 shakes. Awesome. Thank you very much for watching, and I will see you in class.